it's Olivier. I worked on OhGnome this semester, and I'm gonna walk you through my contributions. I would like to make a quick disclaimer that I worked on a lot of stuff in this project, and so I had a hard time picking what my heroic contribution is, because in my eyes personally, a lot of the stuff I did was kind of equal importance to the project. So, for what I pick, I'll pick something, but just know that I think of everything I did kind of the same way, so it's a little weird for me. I'm going to start by showing off my non-programming related things, just because although I am a programmer, I did do a couple things that weren't programming related. So anyway, the first thing are these nice, lovely round health bars for the flowers. So they each have one, just to show you how much water they have left. And I made this using a shader, so as you can see here, you can adjust the amount of fill, and if it goes below a threshold, it turns red to signify there's not enough water for it to attack anymore. And I can open the actual shader for it. It looks very complex, it's not too bad. Basically, it relies on the fact that you can get these gradients, which create circles. So if I just plug this directly into the final color, you can see these create circles, and then I do some math to subtract one circle from another circle, and then it all works out in the end. And then I do some math along with this this dynamic branch, which sets the color appropriately. So red if it's below a certain point, and green if it's above a certain point, as well as this gray to set the background of it to a darker color. And then I think this is the thing that I use to make it actually change how much, like how filled it is. So if I put this in here, you'll see it basically just creates this gradient from 0 here to 1 all the way over here. And when I adjust, I'm essentially raising or lowering those numbers and then clamping them back to 0 and 1, which gives me the progress bar effect. The next thing I did was this watering particle system here. It doesn't look too great in this inspector, but it looks a lot better in the game. I made a couple discoveries while making this. One was that the color of the particle, which should have been from here to here, wasn't appearing correctly, and that's because of the way Unreal Engine handles unlit materials, which is essentially they make them emissive instead of just rendering the color directly to the screen, which is how I would expect them to work. And so I had to end up making my own custom material that was just lit, and that ended up looking a lot better, so I just went with that instead. You can see here I made a little material for that. And another thing was inheriting the velocity. So basically you'd move around and you'd shoot your water, but then if you were moving forwards, the water wouldn't shoot as far because they wouldn't have as much velocity compared to their parent velocity. So I added this inherent velocity node, and I lowered it so that it inherits 90% of the parent's velocity. I tuned that for quite a while, and that's just the number I ended up enjoying, and I can yeah, like it's a pretty nice system if I do say so myself. The next thing I made was this dirt shader, which when you first look at it might not look very complex. It's just some noise that's mapped to some different shades of brown. But when I go into plain view, you'll see I had it fade out the edges and also fade out the lighter parts before the darker parts, which, whew, that was a little bit of a challenge. And I still am not entirely happy with it, if I'm being honest, but it's good enough. It looks pretty good in the game. It's a lot of math of taking gradients and adding them and dividing the numbers, and I'll be honest, a lot of it goes over my head. Even though I didn't use a tutorial or anything for this, I just kind of made it, but it's a bit of a miracle that it worked out. But as you can see in the game, looks pretty good, especially from far away. Like, I just thought that a harsh transition would look a little bad, so I did that. I also, while I'm in this section talking about the path, wanted to mention that technically, very technically, I added a model into the game, because for this spline, it uses meshes to like instance along the spline, and it moves their vertices so that they kind of warp to the shape. But there wasn't a high polycount plane in the engine by default, so I made this lovely sm underscore subdiv plane, which is my beautiful asset of a plane that is subdivided, I think like 10 times or something like that, just so that it would warp correctly with the path. So I'm an artist now. I also set up the input mapping for the game, so I have my different input actions, and then I have my mapping context. I did end up getting some help from Megan with the controller support just a few days ago because I didn't have a controller, so I wasn't able to test for that for a long while. I some of it's a little sketchy the way it works, and it's in the hero blueprint, and I'll show that off later. But I did the keyboard and mouse mappings here. One thing I learned, which was pretty cool, specifically for this, I use one input action for the movement, and I map W, A, S, and D to it, which you would think, well, how is it going to know which direction? Because you can negate it, but you can also, so this one has, they have smooth modifiers on them, but some of them should have swizzle and negate. So swizzling just takes the input value, and because I set it to be a two-dimensional input value, if I go here, it's an axis 2D. So basically, whenever you press any of the keys by default, they return essentially a positive number in one axis, let's say X, for example. And so W returns positive, or let's say Y. W returns positive Y, and A or S should return negative Y. So we negate it. Then A should return positive X, and D should return negative X. So we swizzle them, which changes which of the two axes we're affecting. So that was a cool thing to discover. So you don't have to make two input actions for that. Next up, I have the well blueprint. So this marks the start of me looking through more code-related things. The well blueprint is a fairly simple one, but I did end up using the construction script for this one. I think this was a little bit after we were first introduced to it as a concept. And basically, it has a little sphere, an overlap sphere, and I have a value for the radius of it that you can edit within the inspector, and I do that in here. And I also used to have a visual thing, this cylinder or the other cylinder. I can't remember which one. One of them was a cylinder which represented the actual model of the well. The other one was a very flat cylinder that represented the circle of how big it was, because you couldn't actually tell in the editor and it was getting confusing. We ended up fixing that with an asset that Rain made, but yeah, so you can't really see that anymore. Anyway, the way it works is we overlap with the player, and then I have to do this special check because the player has multiple overlap colliders, and one of which is for watering and kind of juts out really far. So we're having some weird behavior with that. So I just check that it's the correct component that we're overlapping with, and if it is, we call the fill water on the player, and then sound stuff and particle stuff wasn't me. This is the blueprint for the projectile, and it's more of an honorable mention more than anything because there's no code in it. I actually think I removed some code, which is why there's not even like the default boilerplate stuff. Basically, it uses projectile movement, but I'm taking credit for this because I figured out that if you set the homing acceleration really high and you turn on homing projectile, it won't miss the gnomes anymore. This is the spline blueprint, which I made. I followed a bit of a tutorial on how to set up a spline to automatically generate geometry around it using a construction script. I don't entirely understand it because in my mind we would be making a whole bunch of these spline mesh components, but maybe that's just how it works. But it does work, which I think means I can take full credit for this asset because I made the texture and I made the blueprint and I made everything about it. So that's pretty cool. There are some values here that were just for testing purposes when I first made it, and they just kind of never got removed. This is the plant blueprint. It was originally made by Alex, but then I ended up modifying it to kind of simplify it and make it more consistent. So Alex originally made it using Unreal's AI components, but that ended up kind of being a little sketchy with how well it worked. And so I kind of replaced all that with just using good old collision checking and, oh, I mean, like overlap checking and whatnot. This is the base class for all the plants in the game, so it's got a whole bunch of variables for stuff. It's got, I didn't architect it originally, so like for example, this look at target unchanged from when it was an AI because the target that we try to find is still the same, which is, you know, good code on Alex's part. Watering it, you just add a little bit of water. We have some wilting, which is just taking damage, and then there's this calculate health, which is a little bit of a messy blueprint, but it calculates the health of the plant based on a delta, so it can either be positive or negative depending on if we want to add or subtract health, which is useful for both watering and wilting. And then we're also updating their health bars based on that number. And then, yeah, I think that's about it, other than the main event graph, which is just checking if there's anything within the radius and setting an array and also finding the first enemy to look at. So we do this by checking how far along the path they are, because every enemy has this little progress value, which is a percentage of how far along the path they are, and we just check for the one that's the greatest. And then it'll aim at the first enemy. That's basically it. Next up is the projectile plant, which is based on the base class of the regular plant. Basically, it shoots is essentially what it does. I didn't really make this originally, but then I adapted it to use the non-AI code. And yeah, so it's just got this little shoot thing where it'll spawn in a bullet and then give it some velocity and set the homing target. And then here we have this is shooting variable is for the animation so that it knows when it should be playing. And then we have some delay so that it's not constantly shooting all the time. And a little check for if there's some enemies in the radius, and then it'll start the shoot loop, but it's on a do once so that only after it's done shooting can it do it again. This is the blueprint for the melee plant, so it's like the area of attack plant, this one. And I didn't contribute too much to this one in like a literal sense, but I did. It was more of a pair programming affair. This was kind of being developed while I was reworking the plants to be a little simpler. And so once I was done doing that, I went over and helped develop this, but also it was broken for a while and Alex fixed it. So giving most of the credit to Alex for this one, but I just wanted to mention that I did help make it. So I don't know. This is the blueprint for Grandma. I kind of made it when I didn't have that much experience with blueprints, so there's a lot of well, I should be using more events, I should be using more functions, but you know, it works even though it's a little messy. I did use one function, so when Grandma goes near the well to fill the water, I have this function that the well calls on Grandma, which I thought was pretty neat, and it just takes the water and fills it back up to full, so we set water back to max water. So now we're going to dig through the weeds a little bit here. So we have our event begin play, which we have this nice little sequence for. We set the input mapping. We possess a camera, so I have a camera in the scene under a blueprint, which I'll talk about later. And we just possess that one with 0 blend time, so it does it instantly. Then we create the cursor blueprint, so it's just a blueprint that follows the mouse cursor. And then we set the max water to the water, so basically only the water is visible within the scene, so you can see there. And so we just set the max water to whatever value this is set to, so that they're both set to the same thing when the game starts, and we fill up our water by default. Okay, next we have player movement. I added my own motion smoothing because I received some complaints about the movement feeling too jittery, although I wasn't there on that day when I received those complaints. But it seemed to have tamed the masses. So it's some very simple, we get in the stuff, we normalize it. We get the this part's a little special. We get the forward vector of the camera and the right vector of the camera, so that we could reposition the camera and the player would always move relative to it. So you press up and it's always up within the space that we're viewing. I thought that was pretty neat. And then just simple add movement to pawn. And then we have the mouse-based look rotation. This I stole directly from my twin stick shooter like demo project. Basically, we're just casting a ray from the camera down to the world, and then at the mouse position, and then looking at it. Pretty simple. But then we also have this part, which could have been done better with some input mappings, but it was done like yesterday. Megan kind of architected the main bulk of the code, and I just got it working in the end. So it just uses the thumbstick, and then we project a world location. The main part was that Grandma was rotating, but the cursor wasn't rotating with her. And we ended up fixing it by projecting from the screen to the world location, and Megan had put a little point at the end of this. I don't know if I can select it. You'll just have to believe me, I think. Oh, there we go. No, no. You know what? I swear, there's a little point at the end of this thing somewhere. um, and that's what it's looking at. Yeah. Anyway, I got distracted there. This is, I don't actually know what this is. This isn't hooked up to anything. So that's probably previous Megan code for that. Then we have the glorious, I call it glorious, but it just kept expanding, the watering code. So you get the input for having the mouse clicked, and then if it's triggered and if it's completed, we branch off in two different directions. Basically, if it's completed, we are stopping the watering. If it's triggered, well, then we're starting this whole sequence of events. So basically, I have this infinite water thing. This is for the tutorial, which I'll talk about later. But if we have infinite water, we want to fill up the water while we're shooting. If the water is less than 0, then we want to go back down to stop watering. There's also some stuff with Rain put in a nice little particle effect for when the hose is empty, so there's some stuff in there for that. And then here we use up a little bit of our water, and then we find the game mode. I'm not exactly sure why we do that. Probably some old version of the code needed that. Anyway, then we find the watering meter. Oh, that's because the watering meter used to be in a HUD that was contained on the game mode. But then we moved it on to the player. So we get the watering meter from the player. We update the watering meter. Then we activate the watering effect. So there's this, it's called watering, and just literally it's like turning on a Boolean, activate it. So you can see that you're watering, and then we deactivate it on when you stop watering. It's a bit of a messy code. So then we have this sequence. So first we go up here and we loop through a whole bunch of plants. This whole thing was because for some reason it wasn't finding their hitboxes, so I was trying to see if it would find their hitboxes. But anyway, we loop through a bunch of stuff. We see if they're plants. Well, we loop through the overlapping plants, and then we water them if they're there, and then we clear the array, and then we do it all again the next time. And then over here, we do essentially the same thing, but with the gnomes, and then we call get pushed on the gnomes. And then if we stop watering, we turn is watering to false, we clear the gnomes, we clear the plants, we loop through the gnomes, and we tell them to stop being pushed, of course, before we clear them. And that's how the watering works. And then lastly, down here, I have this little bit of code that positions the water meter next to Grandma, and it always positions it on the opposite side that she's facing, so that's never blocking what you're trying to aim at. Use up water was a nice little thing that I separated out. I don't know why I didn't separate out more of that. And then position water meter is done on tick because I was getting weird behavior when it wasn't done on tick. So that, I think, is, in essence, Grandma. probably could have been my heroic contribution, but I'm going to pick something else for it. So next up is the gnomes, or I suppose the BP underscore enemy. This is the base class for the other enemies, but I didn't work on any of the other ones, so I'm just talking about this one. I kind of worked on this collaboratively with Alex. Again, it had to do with the refactor from using the AI system to not using the AI system. So, in essence, what I added was mostly this, and then there's a little something else. So we get a reference to the path to follow, and then using all this beautifully formatted code, we we just move along it a little bit, so we get the length of the spline and we map it to a range of 0 to 1 so that it's I just kind of like having the normalized value, and then you just add a little bit to the progress and then move the gnome to be at some point along the progress. So here we do that, we get the transform distance along the spline, and then we set the actor location, and then we also set the actor rotation to the rotation of the distance along the spline. Or actually, this is where we do the original set actor location. This is for when you get to the end. There's a separate spline to spread out the gnomes at the end of the path when they're eating cookies, because they used to overlap and people were getting confused. Anyway, I think in a way I kind of made this a tick loop because I'm using the delta seconds from the world as the delay value. And then it just calls itself again right after. So I think technically it's kind of like tick, but technically not tick. So do with that what you will. And then at the start, we just kind of get our references and we call this for the first time so that it can loop. Then the other big thing I added was this, which is when we overlap with another gnome. So we're overlapping with a gnome, and it's not us. We're not overlapping with ourselves because the gnomes have two colliders for whatever reasons. I used to have this work two ways. So basically, if you are the gnome in front, you get pushed forward a little bit, and if you're the gnome behind, you get pushed backwards a little bit. That got too confusing. So now, if you're the gnome behind, you get pushed backwards a little bit. Which we do by just checking the target progress and your current progress, so the progress of the gnome you've collided with in your current progress, and we see which one's bigger. And the distance at which you get pushed back a little bit, I had to do some math, so I get the size of the gnome's colliders, and then I had to do some weird stuff. This divide by 1 doesn't have to exist. A lot of this doesn't have to exist. But basically, we get the length of the spline, we divide it by the gnomes to find out how many gnomes can fit on the spline, and then we move it back by what is essentially 1 gnome's worth of space. And that seems to work fairly well. There used to be a different solution where I had a hard-coded number, and that worked fairly well at higher frame rates, but at home I like to develop at 30 frames per second because it keeps my computer nice and quiet. And I had noticed that it wasn't really working then, so I developed this to fix that. It still doesn't work if you back them all the way up to the end of the path. They'll still overlap then, but because you can't really do that in the game, I'm not too worried about that. I did also want to give an honorable mention to BP underscore camera. This is my child. This is my beautiful blueprint that I made with my blood, sweat, and tears. It's a camera, and that's it. I made it just so that we could have one up in the scene, and that's the one that we possess as grandma. It does kind of come in handy more later, which I will talk about, I guess, pretty soon. So this is the tutorial level, and it's what I'm going to call my heroic contribution, even though arguably that should be the player controller, like the hero blueprint. But anyway, we kind of needed this. We kept getting feedback about needing one of these. We kept saying we were going to do it, so I finally did it. It didn't take me as long as Grandma, but I think it's a vital thing to the game, and I'm quite proud of myself with the job I did. I quite enjoy making tutorials, and I just find it a rewarding thing. So I had to make a couple custom blueprints and a couple blueprints that derive from other blueprints from the main part of the game. So I'm just going to kind of go through all of that now. First of all, I didn't know you could place text in space, but that's pretty cool, and that is how this whole thing works. I'll show a demonstration at the end because I can get through it pretty fast. Then we have these zones. If I can select one, there we go. These I call tutorial camera switchers. And basically, when you collide with one, which I had to do the same check for the well, where you check that you're colliding with the correct collider on grandma, we switch to the camera that's associated with that one. There's also some stuff about having infinite water and being the first one. So if you're the first one, it just automatically sets your camera view. I did have to wait one second to do that for whatever reason, but it works smoothly now, so I'm not complaining. And then it just sets infinite water on grandma, and that's just so that you have infinite water during the first parts of the tutorial so that you can be taught what to do. And then when this turns off, you no longer have infinite water and it actually entirely drains so that you have to fill it up. So I thought that was pretty cool. Then we have, I don't think there's anything special. Oh no, there is. There's something special about these guys. Oh yeah, we just set their health to 0 by default. So you can't tell right now, but you have infinite water, and I want to teach you that you have to water the plants for them to attack, because that wasn't clearly communicated to our players before. So I just set both of these guys' health to 0 when they start. The well, I think, is exactly the same. Then we have these gnomes. These gnomes, if I open them up, basically I remove any logic they would have. So begin play, I replace with a print string. I had to do that because if I just had it hooked up to this, it would gray out, so just kind of ignore it. And then also get pushed, I just removed the little hookup there so that it wouldn't get confused by missing references, and that seemed to work out pretty well for me. So these guys will just kind of stand still and die when they need to die. Then we have this guy, who is essentially the same. I just had to unhook up the things and put the print string there. But it's a higher level, I suppose you could call gnome, so it takes 3 shots to die, and that's just to demonstrate that gnomes can have more than, 1 life. That's very philosophical of me. And then we have this final gnome, which is almost a regular AI gnome. But I basically set it to not have an end goal, so it'll just kind of keep walking. There's a path under here. Because of the way I developed the paths, there we go, there's the path. It's a little hard to see. But because of the way I developed the paths, they can be basically anywhere, and the gnome will still snap to a certain Z level. And so I just hide it underneath this decorative path, which is purely decorative. And so this gnome can be pushed back to teach that mechanic. So that kind of goes over all the blueprints I made. Oh, there's also one last one, which is similar to the camera switchers, but instead of switching cameras, it loads the next level. So I made all of those, and then I can press play and I can kind of demonstrate it. You might be able to hear some residual audio from my headphones. I'll turn that down. So use AS and D or left stick to move, aim using the mouse, or right stick. And then when you go to the next zone, the camera smoothly pans. This teaches you that plants can attack gnomes if they're watered, and it tells you how to water. So you water the plant, it kills the gnome. Next one, plants lose water every time they attack. This plant can attack at close range. So teaching about the other plant type, showing that they lose water when they attack. Now, no water left. So we go over here and we refill it. Beautiful. Now, this gnome is yellow, so that means that it can take multiple hits. And finally, gnomes can be pushed along the path. So spray the gnome, go along the path, and now we're in the game. Fortunately, it doesn't load that seamlessly in the actual build of the game, but it's still not too bad. And I do get those yellow warning messages, which is just because I set these unmovable gnomes to stationary, I mean. Because I was having a problem with them moving for some reason, like not moving of their own volition, but the player could push them at certain strange angles. So I just decided to remove that problem. It gets mad at me because they have the controllers on them, the AI controllers. But, it doesn't hurt to have little yellow warning messages. But anyway, that is what I'm going to consider my heroic contribution of the tutorial. I did also want to mention that I didn't do the decoration for the tutorial. That was all Megan. I don't want to take credit for that. So I just did the layout, and then like with the fences and whatnot, and then Megan was the one who came in and extended everything out and put the trees, and it looks real nice now. So that's great. So I think that now concludes my contributions to the game OhGnome. I hope this video wasn't too long, and I hope you like the game, I guess. Thank you for listening.